Hi everyone. Again, welcome to your course, Chemistry for Engineer. Today is another video of the continuation of your module number 1. This is Engineer Junaika A. Tapiador. This is the continuation of our module number 1, which is entitled Energy. And so far, we are already done with the overview of your energy, the energy laws, and now we will be talking about your electrochemical energy. These are the topics that we will be covering throughout this particular video. So the first one is, what is electrochemical energy? As we have been talking about before, in the overview of your energy, we have a lot of types of energy. This particularly will be today we will be particularly talking about electrochemical energy. And it is defined as the energy which converts electrical energy to chemical energy and vice versa. So this is the type of energy wherein you have an electrical energy and then that particular electrical energy is converted into chemical energy, or the chemical energy is converted to electrical energy. The electrochemical energy is related to fuel cells, photoelectrochemical and energy storage systems such as your batteries, supercapacitors, or ultracapacitors. So as you can see the picture here on the left, you have a typical battery. But have you ever wondered how a battery works? In this video, you will be able then to understand how it actually works. Before we start with that, you have to recall first your redox reactions. These redox reactions, I believe you have already taken this up with your chemistry in your high school. So it's very important that you know how to balance your redox reactions. Redox is a short term for what we call your reduction-oxidation reactions. So it says here, the reaction that happens during the production of electrochemical energy is called redox reactions, which includes the transfer of electrons. So there, diba, before, as I've stated before in the previous videos, electrical energy is caused about by the flow of your electrons. And your electrochemical energy is actually a reaction that includes the transfer of those electrons. So let's have an example for your redox reactions as just part of recalling. So if we have this chemical equation wherein you have your iron in a form of solid plus your copper sulfate in an aqueous solution, yielding your iron sulfate or your ferrous sulfate in an aqueous solution plus a copper which is in solid form. If we actually complete the ionic, or if we rewrite this chemical equation into its ionic form, you will see that it's actually like this. Your iron in a solid form plus your copper, which is also an ion having a 2+ charge, plus your SO4 having a 2- charge, yields your, let me repeat that. So you have your iron in a solid form plus your copper in an ion form with a 2+ charge, followed by your sulfate having a 2- charge, yields your iron having a +2 charge plus your sulfate having a 2- charge, and your copper in a solid form. So as you can see, this is the left side of the equation, this is the right side of the equation. We could actually cancel out your sulfate here and your sulfate here, since pareho lang naman po sila. Such that you will have this ionic chemical equation, your iron, which is in a solid form, plus your copper, which is in its 2+ ion form, yielding your iron having the 2+ charge, and your copper having your in the solid form rather. And if we rewrite the two half reactions involved in this, you can see that your iron, which is in the solid form, will yield your iron in the ionic form, having a 2+ charge. And of course, as you know, with chemical reactions, it should be balanced. So we have to add electrons on the right side. 2 electrons to be exact, such that the charge of the right side is equivalent to the left side. So meaning 2 plus 2 negative will yield you a 0 charge on the left side. So diba, 2 plus a negative 2 is equivalent to 0. So equal na po yung charges ng left side and that of the right side. So for the other half reaction, which involves your copper, you have here on the left side, you have a copper ion having a 2+ charge, and it will yield your copper, which is a solid. So again, para po equal po yung ating reaction, you have to add 2 electrons on the left side. Para 2 plus negative 2, kasi negative 1 yun, times 2, will yield 0. So, equal na po si left side tsaka si right side of the equation. And of course, as you have learned before, you need to be able then to identify which actually is the oxidation and the reduction reactions. So here, if we recall, diba, kinapi lang po yung half reactions kanina. So you have your iron and then you have your copper half reactions. How do you know if it is the reduction reaction? So here you have, when it is a reduction reaction, it occurs, or reduction reaction rather, occurs when a species gains electrons and decreases its oxidation number. So if you take a look at copper here, you have a 2+ charge, and then nung napunta na siya dun po sa product side, naging 0 yung charge niya. So meaning from positive 2 to 0, it actually gained electrons kasi nandito po yung electron sa left side. Kumbaga nagdagdag tayo ng 2 electron doon sa reactant side. And nag-decrease yung oxidation number niya kasi from the positive 2 naging 0. So a decrease in oxidation number means that that particular species gained an electron undergoing your reduction reaction. And another one for the oxidation. Oxidation occurs when a species loses electrons and increases in oxidation number. So here on the other hand, yung iron po, siya po yung oxidation because from a charge of 0, it went to a positive 2 charge. And 0 to positive 2 incurs an increase in oxidation number. Therefore, your iron is the one that underwent the oxidation process. And your redox reaction, they actually go hand in hand. So, kung reduction yung isa, dapat oxidation yung isa. Partners po kasi sila. So, hindi pwedeng dalawang reduction or dalawang oxidation. It should be reduction and oxidation. So, another thing that you need to take care of is, that you would need to know is how to identify the reducing agent and the oxidizing agent. When we say reducing agent, this is the ion, the molecule or the element that donates the electrons. And when you say oxidizing agent, this is the ion or molecule that accepts the electrons. So, nandito naman na po siya. I already put in the reducing agent and the oxidizing agent respectively. What I usually do is, whatever is the oxidation or whatever is the species that underwent the oxidation, that's actually your reducing agent. Kasi siya yung nag-cause para ma-reduce yung other element or ion. Same is true with the reduction. So the one that underwent the reduction is actually your oxidizing agent, since it is the one that caused the other ion or molecule to be oxidized. So para siyang partner na pag oxidation yung nangyari sa equation na yun, siya yung reducing agent. And kung reduction yung nangyari doon, ibig sabihin siya yung oxidizing agent. So recall lang naman po ito. So dapat maganda na yung background nyo dito sa redox reactions. We have what we call parang acronym for us to be able then to easily remember your redox reactions. We have the acronym GEROA and LEORA. So GEROA means gain of electrons, meaning it underwent the reduction process and it is the oxidizing agent. So GEROA or GEROA. And the second one is your LEORA or loss of electrons oxidation reducing agent. Such that pag alam mo na or pag na-identify mo na kung sino yung nag-undergo ng oxidation or the reduction, alam mo na rin na kung sino yung nag-gain ng electrons or nag-lose ng electrons or yung oxidizing agent or yung reducing agent. So you have to remember GEROA and LEORA. Tingin ko naman na-introduce na din ito sa inyo noon. Now let's go to the types of cells. So for this particular video, we will be covering two. Your galvanic or your voltaic cell and then your electrochemical cell. Pero mas magfo-focus tayo po dun sa galvanic or your voltaic cell kasi mas siya yung mas nagagamit. Okay? So number one, you have your voltaic or galvanic cell. Meaning this particular reaction generates current. So parang yung typical battery nyo na kung saan pag nilagay mo yung battery, di ba, nagkakaroon ng power yung inyong mga gadgets. The batteries in your cell phones is actually an example of your voltaic or galvanic cell. Ganito po yung nangyayari sa loob ng battery. So you have your zinc here on the anode side and then your copper at the cathode side. So ito pong zinc na to, itong zinc which is a solid form, actually magiging zinc ion siya, having the +2 charge. Now, since naging +2 yan, ibig sabihin, magproproduce yan ng electrons. Okay? Para equal yung charges, di ba, +2 dyan, so ibig sabihin may dalawang electron na kailangang umalis. So, ito na po yung dalawang electrons na yun. Wherein, when it passes this particular wire, tas ito kunyari is a bulb, of course, since there is a flow on electrons, it will generate electricity. Now, those two electrons then will pass through this wire and then it will be consumed by your copper. So, gagamitin po nung copper na yun, yung dalawang electron to yield your copper sulfate solution or your Cu +2 in an aqueous form. Okay. And usually meron siyang dito, we call this a salt bridge. Para po a salt bridge serves as para siyang membrane or partition para hindi po nag-short circuit yung ating reaction. Para hindi po nag-short circuit. So this is a porous disc in this particular video. So we have here, same lang po kanina, ito siya. So anode reaction is oxidation. The zinc atoms are oxidized to your zinc ion. So as you can see here from the solid zinc, naging zinc 2 plus ion siya and may dalawang electrons dun sa right side of the equation. It's an oxidation process, di ba? If you recall, di ba, oxidation meaning, if we go back, oxidation, Oxidation occurs when a species loses electrons and its oxidation number increases. So if we take a look, so yan, di ba, from an oxidation number of 0, naging positive 2. So nag-increase po yung kanyang oxidation number, kaya siya po yung nag-underwent ng oxidation process. So, since si zinc na yung nag-undergo ng oxidation process, it goes to show na dapat si copper po ay magiging reduction process. And this is the particular reduction reaction. Such that, if we balance the two-cell reaction, ito po yung nangyari sa cathode and ito yung nangyari sa anode, you have zinc, which is in a solid form, plus your copper, which is in its ionic form, having a 2+ charge, will yield your zinc ion having a 2+ charge, plus your copper in the solid form. Or usually, hindi na po ito yung pinapakita if you take a look at some references or books or whatnot. We actually simplify this particular reactions into this notation. So parang Zn, tapos ganyan lang, it's a line, Zn2+, and then double line, Cu2+, line Cu. So what this means is that, ito is yung anode, ito po is yung cathode. Or this is the one that underwent your oxidation, and this is the one that underwent your reduction. So, ibig sabihin po nung ganito, and dito naman po yung reference, is your phase boundary, and the two lines there is called your salt bridge. Okay? Or simply, it's the partition to prevent the circuit from short-circuiting. Okay? Now, this is just a summary of how your galvanic or your voltaic cell works. So, number 1, at the zinc anode or your negative pole, electrons are produced by the oxidation reaction, this reaction. And then the electrons generated at the anode will move to the copper through a wire through a voltmeter, giving the reduction reaction, which is this one. And then third one, to maintain balance or electrical neutrality, the cation ions or your positive charged ions will move toward the copper cathode, and the anions or negative charged ions will move toward the zinc ion. Yung movement po is through the salt bridge para to prevent short-circuiting. And then, another type of your cell is your electrolytic cell, wherein the current drives the reaction. Kabaliktaran po siya ng inyong voltaic or galvanic cell. Diba sa galvanic cell, the reaction produces current. So, dahil dun sa reaction, nagkakaroon po ng current or napapailaw yung light or nagkakaroon ng reading po dun sa voltmeter. Pero pag sa electrolytic cell, it's the other way around. Dapat lagyan mo ng current yung particular solution para mag-proceed po yung chemical reaction. And if you take a look on the picture here on the left side of your screen, parang kinumpare lang po yung pagkakaiba ng galvanic and electrolytic cell, which you could actually pause if you want para medyo makita nyo siya. So going now to the next topic, your cell potential. So how do we know? Parang paano ba natin nakakalculate yung energy na kayang i-produce ng isang cell? So the three topics, these three topics will actually show how we get to calculate the volts or the joules or the energy associated with a galvanic or a voltaic cell. So let's go to the very first one. We call it your cell potential. When we say cell potential, or commonly it's referred to as your E sub cell, this means that electrons will always flow from a higher electrical potential sa mas mataas na electrical potential to a low electrical potential. So, kumbaga, yung electrons natin, mas na-attract muna siya, nandun siya sa taas, tapos to reach stability, dapat mag-lower siya. So, pababa yung kanyang flow. Such that, kung nandito yung high electric potential natin, and then nandito yung low electric potential natin, itong gap na to, the gap is called your potential difference. And it is the one that we will be calculating using this particular reaction, wherein we have your E sub cell equal to your E sub ox, which stands for your oxidation, plus your E sub red, which stands for your reduction. Kaya it's very important that you are able then to identify which is the oxidation and which is the reduction reaction, kasi pag-aadin mo sila to get the cell potential. Okay? Where the E sub red may be obtained from the standard reduction potential table. Meron po tayong table wherein you get to identify reactions and then its corresponding potential. So, yun po yung gagawin natin mamaya. Then it says here, the larger the E sub cell value, the greater the current it can generate. So, pag mas mataas po yung cell potential, ibig sabihin, mas marami siyang ma-generate na current or electricity. So, Gibbs free energy. Ano po ba itong Gibbs free energy? So, when we say Gibbs free energy, this is commonly symbolized as your delta G naught. So, parang degree sign siya. Pero usually kasi ang basa dyan is naught. K-N-O-T. So, delta G naught, meaning the change in Gibbs free energy pertains to the maximum work a voltaic cell is capable of. Kung yung cell potential po is kinakalculate niya yung current na pwedeng ibigay ng reaction, si Gibbs free energy naman kinakalculate niya yung pinakamalaking possible work na pwedeng gawin ng cell na yon. And it is calculated as follows. You have your delta G naught is equal to the negative NFE naught, wherein your N stands for the moles of electrons exchanged in the reaction. Your F is your Faraday's constant, which is 96,485 joules per volts mole electron. And your E naught is your standard cell potential. So the last one is actually your NERST equation. So, NERST equation is actually the relationship between the cell potential and the standard cell potential. So, it has this following equation, wherein your E stands for your cell potential, your E naught is your standard cell potential, your R is simply your universal gas constant, which I believe you already encountered in your high school. For this particular energy equation, we will be using this value, your 8.314 joules per mole Kelvin. Your Q is actually the reaction quotient. Your N is the moles of electrons exchanged in the reaction. And of course, your F, as already introduced in the previous slide, is your Faraday's constant, which is 96,485 joules per volts mole electron. So, bakit na-introduce tong si NERST equation? We have to remember na yung cell potential po, tsaka yung standard cell potential, magkaiba po yan. When we say cell potential, that is the potential, di ba, potential difference, as I stated earlier. However, standard cell potential is a special kind of cell potential. Kasi when we say standard cell potential, very particular dyan yung temperature and yung pressure. Under standard cell potential po kasi, the temperature is 298 kelvins and the pressure is 1 atmosphere. However, for cell potential, pwede kasing hindi siya 298 kelvin or yung pressure niya is iba. So, again, pag standard kasi, kaya siya tinawag na standard cell potential kasi yung conditions are standard or ideal. However, pag cell potential, parang any other condition aside from the standard conditions. So, let's have a sample problem para maintindihan natin tsaka magamit natin yung ating cell potential equation, yung inyong Gibbs free energy equation, and of course, yung NERST equation. So, number 1, consider the following voltaic cell at 25 degrees Celsius and atmosphere. This is actually your standard condition, 25 degrees Celsius and 1 atmosphere. So, we have on the anode area, kasi voltaic cell, di ba, I mentioned earlier na pag voltaic cell, kung ano yung nauuna, siya yung anode, siya din yung oxidation, tas kung ano yung nasa kabilang side, that's your reduction, and siya yung nasa cathode. Now, we have your aluminum, which is in a solid form, and then sa other side ng equation, naging aluminum ion siya, having a 3+ charge. Then you have a salt bridge, from your iron having a 2+ charge, naging iron solid siya. So these are the following questions. Which electrode is the anode and which is the cathode? Letter B, write the overall reaction. Letter C, using the standard reduction potential table, calculate the cell potential. And letter D, calculate the Gibbs free energy and the reaction quotient. So, given tayo, of course, you just write that we are given a voltaic cell and this simple notation. And of course, you write the required. So, isa-isahin po natin siyang isolve. So, solution for letter A, the anode and the cathode. So, identify lang po kung ano yung anode or ano yung cathode. So, na-mention ko na pala siya kanina. Nasabi ko na pala yung sagot. Diba? Yung anode mo is the one that's on the left side of the notation, which means it is your Al or your aluminum. Siyempre, since anode na yan, it goes to show na yung kabila is yung cathode, which is in this case your iron or Fe. So, letter B, overall reaction. Siyempre, para magawa po natin yung overall reaction, we need first to identify the two half reactions. So, for the oxidation reaction, you have your aluminum, which is in the solid form, and then it became your aluminum ion having a 3+ charge. And of course, since you have to balance those equation or the equation, di ba kasi 0 po yung charge ni aluminum dito, tapos 3+ yung charge niya dito, para maging 0 siya, you have to add 3 electrons, diba? Such that 3 times -1 is -3 plus +3 equals 0. So that's your oxidation reaction. How about your reduction reaction? Siyempre, si iron na yan. So yan po yung another half reaction of the reduction. So from your iron, which has a charge of 2+, and then naging iron siya, which is solid, having a charge of 0. Again, the left side should be balanced with the right side of the equation. Kaya nagdagdag po tayo dito sa reactant ng 2 electrons. Such that 2+ plus 2 negative or -2 will yield a 0 charge. So, balance na po sila. Now, it was required that we write the overall reaction. Ngayon, if you take a look in the original, meron kang +3 na electrons dito sa oxidation reaction, then you have 2 electrons on the reduction reaction. One thing that you have to remember is dapat po pareho yung number ng electrons for them to cancel out kasi dapat balance siya. Kaya po ang gagawin dito is para balanced yung number ng electrons, this oxidation reaction will be multiplied by 2 and the reduction reaction will be multiplied by 3 para meron kang 6 electrons tapos 6 electrons dito, magka-cancel out sila later on. And sinulat ko na po dito. So, syempre, if you are multiplying the whole quantity by 2, kailangan i-distribute mo si 2 sa lahat. Diba? That's simply your algebra. Such that 2 times your aluminum will give you 2 aluminum, which is in the solid form, and then 2 aluminum, which is in its ionic form, plus 6 electrons. And for the iron or your reduction reaction, you will have 3 iron having a 2 plus charge plus your 6 electrons yielding your 3 iron solid form. Tapos itong dalawang ito, ipag-add mo na lang to get your overall reaction. Which is, ayan na. Diba? So you have your 2 aluminum in its solid form plus your 3 iron which is in its ionic form having a 2 plus charge, yielding your 2 aluminum ion having a 3 plus charge and your 3 iron in its solid form. Nag-cancel out po yung 6 electrons dito. Sorry, let me go back. Nag-cancel out yung 6 electrons dito kasi this 6 electrons is on the right side. Tapos itong 6 electrons is on the left side. So magka-cancel out po sila. So how about your cell potential? So you have your E, diba? Which is your E cell equivalent to the E oxidation plus E reduction. Okay? So, from the table, kailangan po mahanap mo si oxidation tsaka yung reduction values ng reactions. I will be providing you a PDF copy of the reduction potential table para po makukuha nyo doon yung values ng oxidation and reduction potential. So, from the table, diba, ito po yung isang half reaction, your Al3 plus in an aqueous form plus your 3 electrons yielding your Al solid. Ang value daw niyan is negative 1.66. Kumbaga, parang ganito po. Pag na-identify nyo na po yung dalawang half reactions and pinapasolve po sa inyo yung cell potential, hahanapin nyo lang po itong mga half reactions doon sa table. So, punta na po tayo doon. And for the other reaction, ito siya, your iron 2 plus in an aqueous form plus 2 electrons yielding your iron solid. Ang value daw po ng reduction potential niya is negative 0.44. There's a note here. All the data in the table are reduction. So, reduction kasi yung table natin. That's why it's called your standard reduction potential table. So, if you will be using it for oxidation, you have to flip the equation and the sign of the value. So, let's check that. Diba yung aluminum natin, siya po yung oxidation. Basing it from the reduction table, dapat daw pag oxidation yung reaction, if-flip mo yung equation. Diba ganito yung nasa reduction table, and then since oxidation yung reaction, you have to flip it. So, flip ko lang po yung equation. Diba ito kasi nasa reactant side, tapos ito nasa product side. So, binaliktad ko lang. So, ito na po yung aluminum, which is in the solid form, yielding your aluminum ion having a charge of 3 plus 3 electrons. And since you flip the equation, since it is an oxidation reaction, you also have to flip the sign of the potential. So kung negative 1.66 yan, dapat magiging positive 1.66 volts na siya. And of course, dun sa reduction, since reduction reaction yan, wala na pong kailangan baguhin. So, it will stay as negative 0.44 volts. So, let's continue solving. So, ito po yung main equation natin kanina. Since meron na tayong value ng oxidation potential and your reduction potential, i-add na lang po natin silang dalawa. So, that will be 1.66 volts plus negative 0.44 volts, and it will yield you the answer of 1.22 volts. So, yan po yung potential ng voltaic cell or your galvanic cell, which is also equivalent to your standard cell potential or your E0 cell kasi nga it is under standard condition, which is 298 Kelvin and 1 atmosphere. So, ayan po yung note. since the conditions provided are under standard condition, your cell potential is equal to the standard cell potential. Pag hindi po, ibig sabihin, pag hindi standard yung condition, you make the necessary adjustment using the NERST equation. Okay. So, for letter D, we are required to calculate for the value of your Gibbs free energy. And if you recall, this is the equation for the Gibbs free energy. So, you have your N, your F, and your E naught. Which is, meron naman tayo niyan na given na calculate na natin yung values na yan. Wherein the number of moles is 6 moles. Remember po, ito po yung kanina na kinancel out natin na electrons or yung number ng electrons na nag-flow from the higher potential to the lower potential. So, it's very important talaga na ngayon yung makikita how important it is to identify which is the reaction or reduction reaction and the oxidation reaction, and that it's important for you to balance the equation for you to get the correct value of the number of moles. So you have here negative 6 mole of electrons as we have seen earlier, multiplied by your Faraday's constant, which is actually given, multiplied by the calculated standard cell potential, which is 1.22 volts. Ito, of course, this mole electron here will cancel with the mole electron here. This volts on the numerator will cancel out with the volts in the denominator, leaving you with the Gibbs free energy equal to 706,270.2 joules, or in scientific notation, that's 7.0627 times 10 raised to 5 joules. So, diba, it's already in terms of the form of energy kasi joules na po yung ating unit. So, ganyan po mag-calculate na, as I've stated earlier, your Gibbs free energy is the maximum work that particular cell can give. So, in this particular problem that we have, this value is actually the maximum work na pwedeng gawin nung inyong voltaic cell or your battery. Let's have a follow-up question. What if the given voltaic cell operates under 1 atmosphere and 30 degrees Celsius? Using your reaction quotient value of 0.353, what is the new cell potential? So, ito na po yung dapat gamitin natin si NERST equation. Kasi po, hindi na po standard yung condition. It says here the temperature is already 30 degrees Celsius. At diba yung standard is 25. So, kung 30 na yung temperature, meaning hindi na siya standard, how do we calculate the new cell potential? So, of course, ito na po yung mga solve natin kanina. You're given temperature, which is 30 degrees Celsius, pressure of 1 atmosphere, the delta G naught as we have calculated, your standard cell potential, which is 1.22, and your reaction quotient, which is given as 0.353. So, we are to calculate for the cell potential. Solution. So, this is your NERST equation. Na-introduce naman na yan kanina. And then, ilalagay lang po natin yung mga values na meron na tayo. Diba? Si standard cell potential is 1.22 volts. And then your R, sinabi natin kanina na it's actually a universal gas constant. And when we are talking about energy, we will be using this value, 8.314 joules per mole Kelvin. And of course, your temperature, diba? It was given as 30 degrees Celsius. However, diba, pag kanina nakalagay dun sa ating NERST equation na the temperature should be absolute. Therefore, yung 30 po kailangan i-convert siya sa Kelvin scale. And when you convert a temperature in degrees Celsius to Kelvin scale, you just add 273. Such that 30 plus 273, naka-Kelvin scale na po yung ating temperature. Then multiplied by the ln of your reaction quotient, which is given as 0.353, divided by Yung N ulit, which is the number of moles, we already obtained that as 6 earlier. And of course, multiplied by your Faraday's constant, which is given as this value. Such that, if you try to take a look, magka-cancel out po lahat ng units na yan, leaving you with the potential under 30 degrees Celsius, which is equivalent to 1.2245 volts. So, kung titingnan nyo po, mas mataas po yung ating potential pag mas mataas yung temperature. Kasi po, the higher the temperature is, kumbaga mas na-excite yung ating electrons na mag-flow kasi may init. So, the higher the temperature is, the higher the voltage it can give out, or the higher the cell potential. Yan po yung isa sa mga tatandaan nyo. Pero pag mas mababa yung temperature, mas, kumbaga, mas mabagal yung flow ng electrons. So I think that's it for this particular video. Next topic, we will be covering your nuclear energy. And you have an activity for this particular video. Please check your assignments tab in Canvas to be able then to do the activity. And please make sure to pass your activities before the due date that is set to avoid deductions. So thank you for listening, class. Again, this is Engineer Janaika Itapiador saying stay healthy, stay home, and stay safe. Goodbye.